So what we want to know here is when we have a positive number added to its reciprocal gives the least or the minimum sum. So what we need to do is we need to define what our positive number is going to be. Let's call it x. Now, since this is just a numbers question, we can't draw a diagram. It's not appropriate. But we do need to find the function. So we'll call the function s. Why s? Because we're finding the sum. The sum of the number, so x, and its reciprocal, so x plus 1 over x, or x plus x to the minus 1. So there's the equation. Now where's the domain? We're talking about a positive number. So positives start just after 0, and they go to infinity. To find the minimum, we need to use the derivative. So s prime, which will be 1 minus x to the minus 2. Or 1 minus 1 over x squared. To find the minimum, we want to know when that derivative is going to equal 0. The biggest issue that we have right now is that we have x squared, our variable, in the bottom. So if I take everything in that equation, multiply by x squared, I'll end up with 0 equals x squared minus 1. I can take the 1 over. I can square root both sides. And I get plus and minus 1 as x. Now, I am going to write these separately just for a moment. Because what we have to do now is these numbers, they're called critical numbers. They're the ones that could result in the minimum. X equals negative 1 doesn't fit in the domain. The domain is from 0 to infinity, so we reject that one. X equals 1 does fit in the domain, so it's a possibility. So we need to test which of these numbers will actually give us a minimum. So if we start by testing x equals 1, go back to the function, substitute in 1 for x, we get a sum of 2. The other numbers that I would test for the minimum would be the endpoints of the domain, so 0 and infinity. However, because these are open intervals, 0 has a rounded bracket, so does infinity, we don't actually have anything else to test. So this critical number is the only place where we could have a minimum. So what we know is that the number is 1. That's what we found up here when we set the derivative equal to 0. And also the least possible sum is 2.